Hey everyone! Welcome back to ZoomInData. And this is episode 15 of our KQL Concepts Deep Dive series. Today we are exploring calculated columns, how expressions are evaluated, and the side effect-free design philosophy in KQL. We are keeping everything pure concepts and interview focused. If you missed episode 14 on time-relative filtering theory, it's worth catching up. Let's get started. Here is our roadmap for today. Calculated columns add new columns computed from existing ones. Expressions are evaluated row by row during query execution. Side effect-free design means expressions cannot modify state. Evaluation happens lazily and only on needed rows. Calculated columns are ephemeral unless persisted via materialized views. Understanding this helps explain performance and safety in transformations. Let's dive into the details. Let's start with what calculated columns actually are. Calculated columns are derived using expressions in extend or project. They exist only during query execution, not stored in the table. Common uses include formatting, unit conversion, and flag creation. Expressions can reference other columns or constants. They are computed on the fly for each qualifying row. This makes them flexible but also ties their cost to the number of rows processed. Now let's look at the expression evaluation model. Expressions are evaluated row by row in the pipeline. Evaluation is lazy, only computed for rows that reach that step. Columnar engine evaluates expressions only on needed columns. Dependencies are resolved left to right in the expression. No caching of intermediate expression results across rows. This row by row, lazy model keeps memory low but means expensive expressions scale with row count. Take a look at this pipeline flow diagram. It shows exactly how calculated columns get evaluated in KQL. It starts on the left with the source table, flows through, where. Notice the lazy funnel icon shrinking the data early, filtering out rows before we even reach the calculation. Then we hit extend, calc col, zoom in here. Each qualifying row gets its own little CPU icon and arrow. The expression runs row by row, one at a time, only on the rows that survived the filter. No work wasted on discarded data. Finally, it flows to summarize. By now the data is tiny, so the aggregation is cheap and fast. The whole magic. Lazy evaluation plus early filtering means the expensive per row calculation in extend only happens on a small subset of rows. That's why smart ordering keeps KQL blazing fast even when you're creating new columns. The big philosophy here is side effect-free design. Expressions in KQL are pure functions, no side effects allowed. No mutation of external state, variables, or tables. Deterministic. Same input always produces same output. Enables safe parallel execution and optimization. Side effect-free design guarantees predictable and thread-safe behavior. This is why you can trust KQL to scale across thousands of nodes without unexpected results. Here are the performance and safety trade-offs. Calculated columns cost CPU per row processed. Expensive expressions scale linearly with row count. Safe parallelization thanks to side effect-free guarantee. No persistence unless materialized. Avoid storage bloat. Use extend early only when downstream needs the value. This balance gives you flexibility and safety without hidden surprises. Look at this balance scale. It captures the core trade-off with calculated columns in KQL. On the left pan, performance cost, CPU icon plus those growing row count bars. Every calculated column costs CPU per row. The more rows you process, the heavier this side gets. On the right pane, safety and parallelism, lock icon and parallel arrows. Side effect-free design means expressions are pure, deterministic, and can't mess with state, so KQL can safely run them in parallel across thousands of nodes without surprises. The middle arrow tipping the scale, side effect-free. That's the genius philosophy. It gives up a bit of raw speed on large row counts to guarantee thread safety, predictability, and massive parallelism. You pay in per row compute, but you gain rock-solid reliability at scale. Worth it every time. Why does this topic matter in interviews? Interviewers ask about expression evaluation and safety. Common questions include, are KQL expressions side effect free? And, how are calculated columns evaluated? Understanding side effect free design shows deep engine knowledge. This topic appears in performance and architecture focused roles. Explaining evaluation model demonstrates optimization thinking. It's a subtle but powerful way to show you understand how KQL stays safe and fast at scale. To wrap up, calculated columns are ephemeral, row-by-row computed fields. Expressions are evaluated lazily and only on qualifying rows. Side effect-free design ensures determinism and parallel safety. No state mutation, pure functions only. Use them judiciously to avoid unnecessary CPU cost. This combination of flexibility, safety, and lazy evaluation is one of the quiet reasons KQL scales so elegantly. That's episode 15 done. Thanks for spending time with me on ZoomInData. Next in episode 16, Null Semantics Deep Dive, we will explore three-valued logic, coalesce, is null versus is empty, and how nulls behave in KQL. Homework to lock this in. Explain to someone or out loud, why are KQL expressions side effect free? Think of a real use case for a calculated column in logs. Answer this one. How does lazy evaluation affect calculated column cost? If this helped, like the video, share it with anyone prepping for Azure interviews, subscribe for episode 16, and drop a comment with your biggest takeaway today. Thank you so much for watching ZoomInData. See you next time. Keep zooming in on those concepts. Bye for now.